So this is an example of one of the questions that you get asked in 16D, which is about instantaneous rate of change. By considering the secant through the points where x equals 1.2 and x equals 1.3, estimate the instantaneous rate of change of y with respect to x at the point on the curve where x equals 1.3, and there is my equation. So what we need to do is say, well, okay, the first things first, we need to find, so this is going to be our first point, and this is going to be our second point. So the rate of change is going to be f of b minus f of a divided by b minus a. So this is the rate of change. And we are looking at, so this is, so f of 1.3. Remember, f of x is that there. So we need to find out what f of 1.3 is, what f of 1.2 is, and then go from there. So let's bring up our Mr. Kaz. So I'm going to pop the Kaz up on the screen as well so you guys can follow along, because your Kaz will help you a lot with this sort of stuff. We'll pop it down here for the time being. It doesn't need to be that big. So if you guys remember, we can do what's called define. F of x is equal to x cubed plus x squared. Done. So then when I type in f of 1, f of 0, f of 2, it gives me all the answers. So now what is f of 1.3? Beautiful, 3.887 minus f of 1.2, 3.168, all divided by 1.3 minus 1.2. We can simplify that, cancel some things down. So it's going to be 3.887 minus 3.68. So obviously the 3's go away, so we're just worrying about the decimals. 0.887 minus 0.168 means that we get 0.719 over 0.1. So what is 0.719 divided by 0.1? And the answer is, now this is approximately 7.19. So the gradient at that point is going to approximately be that point there. For reference, the actual gradient at that point is going to be interactive the actual answer is about 7.67. So it's pretty close. We're close, we're not perfect. We can do it better by getting more and more closer to the actual answer. So we could redo this question and say, well, instead of it being 1.2, it's a 1.2, for example, 1.2. What about if it was 1.29? We get even closer. All right, and we can find out that and get it much, much easier. So don't worry about all the fancy words. I'm actually not a fan of using these words. I prefer to ask straightforward questions where I'm not worrying about the words chord or secant or tangent. I tend to just do away with those. So if you have trouble pulling out those words and getting rid of them, ask me and I will help you as best I can. By the way, there's the working out for that one there.